So we have section 6.2. When we did 6.1, we did law of sines. And the law of sines was useful when we had either two angles and a side or two sides and an angle. And again, this was the case where we had to be careful. Okay, now what we're going to look at today is when we have two sides and an angle. We would not be able to use law of sines in that scenario. So we have what is called law of cosines. And here are your formulas for law of cosines. The general idea is that we would be given two sides. So let's say side A and side C. And we would have to know the angle between those two sides, angle B, in order to solve for the side across from angle B. So here is the formula I'm referring to. If I want to solve for side B, I would have to be given these two sides and the angle in between them. And I would take side A and square it, plus side C and square it, minus 2 times A times C times the cosine of the angle in between. And it doesn't really matter what information. Here, I'll just use the same picture, but I'll use different colors. So, for example, if I'm given side B and side C and angle A, then I can find the side across from angle A. So I'd be referring to this formula here. So if I want to find A, I take B squared plus C squared minus 2 times B times C times the cosine of angle A, because that is between these two sides. So two sides and the angle in between them. All right, so we're going to practice a few examples. So we're going to solve this triangle. So here do you see where I've got side and then an angle and then another side. So this is side, angle, side. I would not be able to use law of sines because I don't know the side across from this angle, and I don't know this angle across from that side or this angle across from that side. It's not going to work. Law of sines just won't work. So we're going to do law of cosines. So if I want to find the side across from angle Q, that would be lowercase q. So I'm going to do q squared equals these two sides surrounding the angle squared and added up. And then you do minus 2 times those two sides multiplied together times cosine of the angle in between the two sides. So you would type all of that in your calculator and you're going to get 277.255, and remember you need to take the square root of that. So little q will be 16.65, and our sides are measured in inches. Once you have these three sides, now if you want to solve for either angle P or angle R, you could switch to law of sines if you want. And the general rule is, as long as you know the largest angle, then you can switch to law of sines. I'm going to write that down. You can switch to law of sines once you know the largest angle. And in this example, 104 has to be the largest angle in this triangle, because I can never have more than one obtuse angle in a triangle. This is obtuse, so there's only one. So I can now use law of sines if I want. I can do sine of 104 divided by the side across from it, which we now know is 16.65. And then I can do either angle. So maybe I'll do sine of, let's just do angle R, how about? And that will be divided by the side across from angle R, which is 12. And when you cross multiply and solve that, you're going to get, for R, you're going to get 44.37 degrees. All right, and then lastly, if I want angle P, I'm going to do 180 minus 104 minus 44.37, and angle P will be 31.63 degrees. All right, and remember, whenever it says to solve a triangle, you find all the missing pieces. So we had to start with law of cosines, but then we could switch to law of sines. Or you can continue with law of cosines as much as you want. There's no issues with law of cosines. Law of sines has issues because of the ambiguous case. That's why you need to know the largest angle before you can switch to law of sines. All right, here's another example. So we're going to go 60 miles due east. And then we're going to turn east 30 degrees south. Okay, so from the east, we're going to bend 30 degrees towards the south. From the east, bend down towards the south by 30 degrees. And we're going to do that for 5 miles. And now the question is, how far away from the point of departure are you? So here was the point of departure. Here's where we are now. I want to know how far away are we? All right, so we've got a triangle. I'm trying to find the side X. So I have two sides, and I can figure out what this angle in between the two sides is. This is 30. These form a linear pair. They form a straight line. So they add up to 180. 180 minus 30 is 150 degrees. So now I can do law of cosines. X squared equals the two sides surrounding the angle, squared and added up, minus 2 times those sides multiplied together, times cosine of the angle in between them. All right, so you type all of that in your calculator. And what do you get? 4,144.62. And you're going to need to take the square root of that, and you will get 64.38. And this is measured in miles. So 64.38 miles is how far away from the point of departure you are. Okay, now the next kind of problem will look like this, where you're given all three sides. So we have an issue because on all the problems we've done in the past, the last few problems, we've had an angle in between two sides. So like I would have the angle between 8 and 15, or I would have this angle between 8 and 11, or this angle between 15 and 11. I don't have any angles. So if I try to use my original formula, we would have to solve for an angle. And we would be plugging in these three side lengths. Okay, and so to solve for this angle, you'd have to rearrange this whole formula. Well, on your formula sheet, on your unit circle sheet, we kind of have them rearranged for you. This might be what you see on your sheet, And if you're solving for angle A, you have to remember that you need to do the inverse cosine of all of this business. So that's why I have it written like this. So if I am trying to solve for angle A, I would need the two sides surrounding my angle, so the b squared plus the c squared, minus the side across from my angle. So the side across from the angle that you're trying to find, that's the one that's being subtracted and squared. And then on the bottom, it's 2 times these two sides surrounding the angle. So side surrounding the angle squared and added up minus side across from the angle squared divided by 2 times the two sides surrounding the angle. Try not to get too hung up on the formulas and understand how the formula is arranged. Now, always find the largest angle first. Again, this is tied to the ambiguous case, and we want to avoid that, so we're going to find the largest angle first. The largest angle will be across from the largest side. So the largest side here is 15, so y is going to be the largest angle. So if I want to find y, I'm going to do the inverse cosine. On the top, I'm going to take the two sides surrounding my angle, square them and add them up, minus the side across from my angle, squared, divided by 2 times the two sides surrounding my angle. Now you should be able to just type this straight into your calculator. You should practice that, make sure that you can do it correctly. You should get 103.14 degrees. So that's our largest angle. Now that we know our largest angle, we can switch to law of sines if you want, or you can continue with law of cosines. Okay, you can continue with law of cosines or switch to law of sines because we know the largest angle. Okay, and again, largest angle is across from largest side. So this is 103.14 degrees. So if I want to do law of sines, I can do sine of 103.14 degrees divided by the side across from it, 15, equals. And then I can choose to find x or find z. It really doesn't matter. Let's say we do x. So then it would be sine x divided by the side across from it, which is 11. And if you solve that, you will get for x 45.57 degrees. And then the last angle, angle z, we can get by doing 180 minus 103.14 minus 45.57. And so then that last angle will be 31.29 degrees. Okay, so these are the formulas you're going to use when you have all three sides. It's the law of cosines just rearranged so that you're solving for the angle. Okay. And then lastly, we have a new area formula. It's called Heron's formula. This is when you know all three sides. So back in geometry, if you were trying to use 1/2 base times height, you would run into an issue. So like if you made 15 your base, the height would have to be perpendicular to the base. And you had a way of finding this, but it was pretty tricky. So Heron's formula is really nice and easy if you know all three sides of a triangle. The first thing you need to do is this part right here. You're going to find this value of s by adding up your three sides, so 8 plus 11 plus 15, and dividing by 2. Okay, so add them up, divide by 2, and in this problem you get 17. Then you use your area formula. So that value of s that we just found gets kind of repeated a whole bunch of times, and then you subtract off each side length. So if I wanted the area of this triangle, it's a big square root, that value of s goes first, and then s minus one of the sides, so how about 8? And then s minus another side, 11, and then s minus the third side, 15. And type all that in your calculator. And the area for this problem is 42.85, and we don't know what the units are, so we'll just say units squared for the area. So this area formula is very nice when you have all three sides.